The objective today is to explain the difference between lossy and lossless compression. This lesson is mostly an investigation of different kinds of file formats that exist in the real world. Lossy compression, also known as lousy compression, is mostly used in visual or audio formats, where a loss in precision is undetectable to human eyes and ears. So I want you to really pay attention to that part, that lossy is used for visual or audio stuff, not so much words. You're going to see an example of lossy compression using text. Just know, though, that that's never done in real life, okay? So think right here, what is compression? We learned about this a while ago. So we're going to play around with that thing I just told you about. It's a text compression widget, and you're going to get to see what lousy compression or lossy compression looks like. So go ahead and go to that link there and have fun. Okay, we're over here on the link, and I apologize, it's just so long and complicated. You can get to it just by signing on to code.org as well. But here is what the widget looks like, and don't freak out over here when you're looking at the code. So if you want to start poking around in here, changing things, seeing what happens, you're more than welcome to. But over here is what I'm talking about, lossy text compression. So here's the original. I have a theory that if you keep the first letter of every word and then remove all the vowels, okay, so it still is going to say something, but if we look at the compression, we're at 22% compression, and it's supposed to essentially say the same thing, and that's it. Your think right share while you're playing around is what is happening in the app. Should this count as text compression? Why or why not? And what do you think lossy or lousy refers to? So at the end of the day, this doesn't count as compression because the decompression is left up to human intelligence and intuition. But if a key was available, then maybe even then lossy compression is never used in real life. So that's why it doesn't count as text compression for two reasons. The first, being the most important one, is that it's your own intelligence that has to finish the work. In computing, when we're talking about lossy compression, the computer will take it from start to finish. And that might be the litmus test question to figure out if something is an example of question. How does the decompression work? If the decompression works because it's human intelligence finishing up the job, then no, it is not an example of compression. If you can't define the decompression, then it's not an example of compression. When we did text compression a few lessons ago, that kind of compression is known as lossless compression, because in doing the compression and in reconstructing the original text, nothing was lost. Every character that was part of the original text could be recovered. Lossy compression, yes, that's the official word, does something else. Lossy compression schemes are one in which useless or less than totally necessary information is thrown out in order to reduce the size of the data. So here's an app reflection for you. The lossy text compression app is not perfect. If you saw the word FD, it could have been food, feed, feud, or fad. It could have been any of those. By reading it in context, you might know what it is supposed to be, but there's no real way to know what the original word was. The original word was lost, and thus lossy. And an interesting side note here is that's one of the most difficult things in artificial intelligence to program, to have the computer read or understand something in context. That is extremely difficult to do. So an example of what I'm talking about is in context, a computer can look at a sentence such as, they go and play basketball. And in context, we would know they as in like the basketball players. But if you said something like the basketball players are playing and they are watching, well, we would assume that the they would be like the crowd or an audience of some sort. The computer would probably get confused in that. How would you program that in to let it understand that the they they're talking about is not the players? You know, us humans and us in our English language, we understand the difference between those pronouns, who the pronouns are referring to. So context is everything. I'm sure you've heard something like that before. All right, so at the end of Unit 1, you were asked to do some rapid research, not only on the second day when you did rapid research to create a rapid prototype, but near the end of the unit there, you were asked to do one of two topics, net neutrality or internet censorship. And then after making the choice, you go and do some small amount of research, come back with the summary of what that thing was. Today you're going to do the same thing, but we're going to do it on a file format type, okay? So here's a variety of files. The strategy here is to look one of these up on Wikipedia, and yes, I love Wikipedia. It's a great source of information. So after looking up this file format on Wikipedia, I want you to use Control F to find keywords to answer these following 3 questions. What type of data is it? So let's say I choose the WAV file format. I'm looking it up. I'm using Control F to search for the word data, and I hope to find out what data type it is, picture, text, etc. The second one is to figure out if this file format is an example of uncompressed, totally uncompressed, lossy, or lossless. And the third thing to find would be, how does it work? So just a couple words on how that file format works. To finalize the lesson here, we have a match table. So in Canvas, you can type in the file format and the definition of it over here. So you have the file formats on the left and the type of compressions they are on the right. And all you have to do is connect those. And I know that'll take you some time, so do your best, get these right the first time around. You can use a table, insert table in a Canvas to make this whole process look a little neater. And the DOL for the day. Using the chart, identify 3 differences that can exist between different file formats.